All right, guys, right back at it. Yesterday what we talked about was multiplying binomials and trinomials, so we made things bigger. Today we're going to talk about the division of it. We're going to make things smaller. So without any further ado, let's get down. First problem looks like this right here. We're going to go 6x squared y. And some of them are going to look a little long and crazy, but we're going to break it down. We're going to make things really simple. Plus 9xy minus 12xy squared. And all of that is going to be over 3xy. So obviously it looks like a big mess right here. What we're going to do is we're going to break this thing down into one problem, and then another problem, and then another problem. So in the end, we're going to have three very, very simple problems, okay? So the first problem, again, we're going to divide just these two terms right here. So this is what I've got. 6x squared y over 3xy. Don't even do any work yet. Just leave it alone. The next thing becomes the plus sign. And now set up the next problem. So it's 9xy over 3xy. Notice that what's in the denominator in both of these little fractions right here, same thing. And it's coming from this. Next thing we have is the minus sign. And then what's on top here? 12xy squared. All of that over 3xy. Okay? So now again, instead of this one big massive problem you're trying to do all at one time, let's do three very, very small problems that you do know how to do individually. So the first one becomes this. What's 6 divided by 3? Everybody in the house knows that's going to be a 2. Whenever I have x squared divided by x, there's two numbers here in the exponent and one here. 2 minus 1, they cancel out. And the only thing that's left is just an x. Y and y, when there's 1 and 1, they both cancel out as well. So the result of this particular problem right here just becomes 2x. Plus sign. 9 divided by 3, I got a 3. X divided by x, they cancel out. Y divided by y, they cancel out as well. So believe it or not, the middle term right here just becomes a 3. Minus sign. 12 divided by 3, let's start off with a 4. The x's right here, what do? You're right, they're gone. How many y's are on the top? There's 2 y's on the top, and 1 y on the bottom, so that would leave only 1 y remaining. So in the end, as tricky as that problem appeared to be from the get-go, it breaks down very, very simply into 3 individually very easy problems that we can work, okay? So now we're going to change it up a little bit, and we're going to do long division. Before I even get started on that, I want to take you back. And when I say take you back, I'm talking about elementary school, when you had some problems that looked as difficult as something like this. 512 divided by 8. And I'm just making up these numbers right here. That's really not the point. The point is this. What did you have to do in order to figure out what 512 divided by 8 was? I had to take the first number right here and see how many times it went into this first number. Well, in this case, it doesn't work, so the first 2. So how many times does 8 go into 51? It's going to be 6 times. And then we know this. Now we got to multiply it back. 6 times 8 is 48. Now, guys, to be real honest with you, what kind of number is 48 right here? Well, it's positive. So what we have to do is change the signs. You're going to hear this being a common theme here in a minute. So 51 divided by 48, I'm left with 3. And now I bring down the 2. How many times does 8 go into 32? 4 times. So now we have a 32. And now what did you have to do with this number right here? Again, you had to change the sign to make it negative so that we end up with 0. Those same concepts and principles are going to be taking place whenever we are doing long division with polynomials. All right, are you ready? Here we go, mixing in some green. I'm going to take it like this. I'm going to go x plus 3. And I want to see how many times that goes into my trinomial. My trinomial here is going to be x squared minus 2x minus 15. All right, so again, looks wicked, looks crazy. The only thing that we need to be concerned with is this number right here, the first number and the first number. So what do you have to multiply times x to get x squared? Well, what we should have is we should just multiply it times x. Now, I wrote it right here over this x. It helps you with your answer in the end. So what's x times x? X squared. Guys, every time that you're doing long division, this first term right here has got to match up with this term right here. Exactly the same. Okay? Don't try to make it negative or positive. Make it exactly the same, okay? Now we're not done. I just multiplied x times x and got x squared. Now I'm going to multiply x times 3 and get a positive 3x. Line underneath, right? But again, coming back over here, what did we have to do? You know it. You're going to hear it over and over. Change the signs. So there was, now there's a negative sign. What does this become? This needs to become a negative sign as well. Now, once we've done that, now I can go about the process of adding and subtracting. So x squared minus x squared is 0. Those first terms better cancel out every time. Negative 2x minus 3x becomes negative 5x. Now, what do we do with that guy? He's got to come down. So now again, we're asked with this question right here. What do you have to multiply times the first number to get the first number? Okay? Well, in this case, I need to multiply x times negative 5 so that I end up with negative 5x. So negative 5 ends up right here. So now I'm going to multiply negative 5 times x and get negative 5x. Are these two terms right here exactly the same? They are, so I keep going. Negative 5 times positive 3 is negative 15. I think this is going to turn out good. Now what I tell you to do right here in the red, change the signs. So this was a negative sign. Now it becomes positive. This was a negative sign. Now it becomes positive. Now when you do this math right here, what happens? Negative 5x and positive 5x, they cancel out. Negative 15 and positive 15, they cancel out. So we're left with a remainder of 0. So what do we know now? X minus 5 times x plus 3. When you multiply those two together using FOIL, you get x squared minus 2x minus 15. I'm going to quickly go through one more example for you. Hopefully that'll be enough. If not, obviously, we've got plenty of time. There are plenty of chances to ask questions. So let's do this. Here comes my new number, x plus 4. And I want to know how many times that goes into x squared plus 2x minus 8. All right, concepts are the same. What do I need to multiply times the first number to get the first number? That's right, x. So x times x is x squared. X times 4, positive 4x. All right, what's the big key? Change the sign. So this becomes a negative, and that becomes a negative. Now we simplify. That becomes 0. That becomes positive 2 minus 4, which is negative 2x. And bring down the 8. What do I need to multiply times the first number in order to get the first number? You said negative 2. You were right on. So negative 2 times x. Negative 2 times x becomes negative 2x. Now also we have to multiply the negative 2 times the positive 4, and we end up with negative 8. There we go. Now what do we got to do? Change the signs. So this becomes a positive, and this becomes a positive. These two terms right here will cancel out. These two terms right here will cancel out, so we have no remainder. So right here becomes the solution to this division problem. All right? So again, you guys attack these, man. You keep those things in mind. What do I have to multiply times the first number to get the first number? First number and first number. And change the signs. If you keep those two things straight, you're probably going to be okay with long division of polynomials.